be looking at percent error. Our formula for calculating percent error is experimental value minus actual or accepted value divided by actual or accepted value times 100. And in our explanation at the top, it tells us that if we are given a positive or a negative percentage, what that means as far as how far off from the number that you are. So if it is negative, your percent error becomes negative. It's that percentage too low. When if it is positive, then it is that percentage too high. So we're going to look at our first example. The question says, a student weighs a solid and records its mass as 98.99 grams. The actual mass of the solid is 101.22 grams. What is the student's percent error? We are concerned with two numbers in this problem. We have 98.99 grams and 101.22 grams. The 98.99 grams is our experimental value. So we have 98.99 grams as experimental, and our actual value is going to be 101.22 grams. Now we're going to plug both of these into our percent error formula. So we have percent error equals experimental minus our actual over the actual times 100. We're going to plug in our numbers where they need to go. So we have our experimental as 98.99 minus 101.22 divided by 101.22 times 100. When you plug into the calculator, 98.99 minus 101.22, you should get negative 2.23. You'll put that over 101.22 and multiply by 100. And when you plug this into the calculator, you end up getting negative 2.20. And that will be a percentage because that is your percent error. Now, percentages are not normally negative. They are usually an absolute value, so that means that they're all positive. This negative sign just means that the percent error was 2.20% too low. So really, we could rewrite this as 2.20% too low, and that would be our answer. In our next example, our question reads, a student measures the volume of a liquid as 50.15 milliliters. His teacher tells him he is 5% too low. What is the actual value of the liquid? This question gives us the experimental. So we're going to write that down. We have the experimental as 50.15 milliliters. It does not give us an actual, so our actual is a question mark. We are going to have to find that, but it does give us the percent error as 5% too low. We should remember that if it is too low, it's going to be a negative 5%. That will make a difference when we are trying to solve for our answer. So again, we're going to plug in our formula. Percent error is equal to the experimental minus the actual over the actual times 100. Now we need to plug in our values where they belong in the equation and then solve for what we're looking for. So we have negative 5 is equal to considered x times 100. Now, to solve this problem, we want to isolate the x's on one side of the problem so that we can solve for x. To do that, we're going to have to divide by 100. So we're going to bring that 100 over, and we have negative 0.05 as our number on the left-hand side, because we did negative 5 divided by 100, and that is equal to 50.15 minus x divided by x. Now, since we are dividing by x, we need to take it over to the other side of the equation. So we're going to have negative 0.05 times x, because it was divided, we have to multiply it on the other side, is equal to 50.15 minus x. We're going to isolate the x's on the left-hand side of the problem so we can get 50.15 all by itself. That x is being subtracted on the right, so we're going to add it on the left. So we have negative 0.05x plus x is equal to 50.15. Since we have two values on the left-hand side that contain an x, we need to combine them. So to do that, we are going to add negative 0.05 to 1. That's an invisible 1 in front of the x. When you do negative 0.05 plus 1, you get 0.95x, and that will be equal to 50.15. This helps us be able to combine those x's so that we can isolate the x and get just a number as our answer. So at this point, we are going to divide by 95 on both sides, or 0.95 on both sides, which will then end up giving us an answer of 52.789, but we're going to round it to 2 decimals, so we have 52.79 milliliters, and that was our actual volume of liquid. So that's our answer for what the actual volume is.